morning, sir.
Good morning, Gurmeen. How are you doing?
Good yourself?
Good.
So we're almost close to wrapping up polynomials.
Yes, we are.
But then also there are other concepts that we still have to cover.
Yes.
So the first and most favorite and most attractive one to me was almost like you make the impossible possible. In a sense, you factor the unfactorable.
Oh yeah, factor unfactorable.
Triple.
That is really tricky and very important to
Right.
understand.
Right.
Yeah.
So, and I'm not that exposed to it because in grade 11 functions we didn't cover much of that. We would just factor quadratics.
Yeah.
In some cases it was factorable, some not. So I want to know about what does this mean, factor the unfactorable.
Yeah. We'll actually take a few examples where I'll show you this technique of factoring
Okay.
unfactorable.
Yeah.
That'll be good. But let me tell you the basic concept.
Okay.
We actually include two principles to do it. One is perfect square,
Yeah.
which is kind of completing the squares part,
Yeah.
and then difference of squares.
Okay.
So we'll combine these two to factor unfactorable.
Okay.
You know, for any trinomial, to factor, you need that product and sum.
Yeah.
The product should be same as coefficient of A,
A.
absolute leading coefficient, and the constant.
Yeah.
And the sum should be B, right?
B,
The
yeah.
coefficient of X.
Okay.
So if that is there, then you can factor. Otherwise, you can't. But we'll
Okay.
take up situations like x to the power of 4 plus x squared plus 1.
Okay.
Now, you know, 1 is 1 times 1,
One.
but when you add them, it is 2, not
Yeah.
1. So you cannot really factor. So we'll go to the board and see how we can factor.
Okay.
Okay?
Alright. Yeah.
That sounds good?
Yeah, sounds good.
Okay, let's go.
Okay.
So here we are at the board, Gurmeen.
Yes.
Let me show you how to factor unfactorable.
Unfactorable,
Okay,
yes.
so let's take that example.
Okay.
We'll do x to the power of 4
Yeah.
plus x squared
Plus 1.
plus 1, right?
Yeah.
Now, as you know, 1 has only 1 and 1, the two factors, right?
Yeah.
You don't get 1 here.
Yeah.
Now, how to do it? That's what we learned. Right?
Yeah.
Basically, we have two concepts. That is, you know what is a plus b whole square equals to?
Yeah.
A plus b whole square is what? Tell me.
A squared
Yeah.
plus 2ab
Yeah.
plus b squared.
Plus b squared, right? So,
Yes.
if I introduce one more x squared here, we get 2ab term. Do you see that?
Yeah.
Right? So that is the concept. So how do I introduce it?
But if you add an x squared, don't you also have to subtract?
Yes, we will. And that
squared.
will bring us to factoring. I'll show you how. So what we will do here is that we'll actually add x squared and we'll also subtract x squared.
Right.
So when you add and subtract x squared, you don't really change the expression, right? It remains the same.
It means the same.
Right. But what it has done is, combining these two, we get 2x squared.
Yep.
So we could write this as x to the power of 4 plus 2x squared plus 1 minus x squared. Do you see that?
Yeah, I see
Now
that.
first three terms are perfect squares. So we
Yeah.
could write this as x squared plus 1 whole square, right?
Yeah.
So that is what we get from the first three terms.
That makes sense.
And we have minus x squared here.
Difference of squares.
Now you can apply difference of squares, right?
Yeah.
So you can factor, right?
Yeah.
So could you write the final answer?
So it would
Tell
be
me.
x
Square
Square
plus
plus
1 plus x
plus x
times.
x squared plus 1 minus x.
Yes, so let's write it down. So it'll be x squared plus 1 plus x times
X
squared
plus 1
plus 1 minus x.
And we have factored
So
in
you have factored, right?
unfactorable.
Do you see that?
Yeah.
That's how you do it.
Okay, so it's really important to keep this balance.
Yeah.
Because if you add, you also have to subtract it.
Yes.
So because you can't change the actual expression, right?
That's true.
That makes sense.
Yeah.
That's so easy.
That is.
Yeah.
So I'll give you another example. Let me see if you could do that.
Okay.
Right? So let me write another example for you and try it out. Okay?
Okay.
So we'll change some numbers here. Okay. So let it be something like this: x to the power of 4 plus, and let's take this as a square of 3, right?
Yeah.
So inside terms should be what?
6.
6. But instead of that, let me put 5x squared, right?
Yeah.
So that is unfactorable, right?
Yeah.
Can you factor this one now for me?
I guess so.
So try it out.
Can we change direction?
Yes, sure. Let's
Okay.
do it. Let's do it.
No problem.
Yes.
So what you can do is that this is same as 3 squared. So 3
Yes.
times 2 is 6,
Yeah.
but you got 5.
Yes.
So you can add an x squared
Yes.
to make it 6.
Yes.
So basically you could have it x to the power 4
Perfect.
plus
Mm-hmm.
5x squared
Mm-hmm.
plus 9
Yeah.
plus x squared
Right.
minus x squared.
Perfect.
So when you add these two,
Yes.
so when you have added this and that,
Right.
you get, another way to write this is x to
Whole
power of
square.
2
Perfect.
plus 5x squared plus 1x squared, 6x squared,
Yeah.
and this could be written as plus 3 squared
Yes.
minus x squared.
Yes.
Now what do we notice?
Yeah.
We have to notice these 3 terms,
Yes.
right?
Correct.
We have to notice these 3 terms. So another way to write this, it would be x squared plus 3 whole squared
Yeah.
minus x,
X
squared.
squared. Right.
Now you got, we're going to use the short form DOS, so
Yeah,
difference of squares. Basically,
Yeah.
you could write this as x squared plus 3 plus x, but you got to arrange it in decreasing order of degree. So in the best way to write this would be x squared plus x plus 3,
Yeah.
that's 1. Another one would be x squared minus x plus 3. And you have factored this term already.
Perfect. So this x squared has been written as plus x and
Minus x.
And we have written x plus 3 both sides. Right?
Yes.
And you have also arranged them in decreasing order as
Yes.
it should be.
As it should be.
That's the perfect answer for
Right.
me. That's
But
a great job.
This is